An aircraft with an empty weight of 3,000 pounds and an empty weight CG of plus 25 was altered as follows. Okay, so some items happened to this aircraft, but originally we have our empty weight of the aircraft. So whenever you're doing this empty weight was already given for this aircraft, but you as a mechanic may need to roll an aircraft up onto scales or use load scales and jack up the aircraft, and you're going to get the empty weight. And then from those load points, those points where your scales are at, you will do an empty weight calculation. But this has already been done. So the idea is we know the empty weight of the aircraft and we know the empty weight CG. So the empty weight CG is positive 25, as we know. From the datum, wherever the datum is set by the manufacturer, it's going to be aft of the datum at 25, because plus is this way is plus and minus is forward. So here's our center of gravity right here at 25, but what happened was some modifications were done. So just so you know, repairs and alterations are the most common reason for weight change in aircraft. So let's go ahead and go to our problem. So we have two 20-pound seats located at plus 50 were removed. So 50 back aft of the datum, we had two 20-pound seats. So that actually should be a 40. So that should be 40 pounds removed from the aircraft. All right, so perfect. And then so we'll go ahead and just start working the problem. So what we're going to need to use is our formula again, wham. So we're going to have wham. So first we're going to do our empty weight. So we have 3,000 pounds. That's the empty weight. And the arm is at 25. And it's going to equal our moment. So we have our second item. So we have 40 pounds. But this 40 pounds was removed from the aircraft. So when we add weight, it's going to be positive, but when we subtract weight, or remove weight, it will be a negative. And then this weight was at 50 inches from the datum. Okay, the number 2 item is the structural modifications were made at plus 62, increasing the weight by 45 pounds. So at plus 62 from the datum, we increased by 45 pounds. So we'd have 45 times 62. Then we would have another modification. A seat and safety belt weighing 32 pounds was installed at 79.5. So we added more weight, and it was 32 pounds at 79.5. And finally, we have 22 pounds were installed at 95. So adding 22 more pounds at fuselage station 95. So what we need to do is go ahead and multiply our weight times our arm and get all of our moments. So we can do that. So the hardest part about these weight and balance problems is that they're just they're just tedious. Here's where you're going to make probably the mistake that everybody makes. So make sure that you have your negative sign. So negative times a positive is going to be a negative. So do include your negative sign. If you don't, you will get the problem incorrect. All right, so here's all of our moments. Again, the place where you're going to make the biggest mistake is just using the calculator, putting in the wrong numbers, accidentally hitting one wrong button, because you have to do a lot of calculations. Okay, so what we're going to do is add up all of our weights, add up all of our moments, and what we're trying to find is our new center of gravity, this arm, so we don't use the arm portion of it for this calculation. So again, here's where you're gonna make your mistake. 3,000, it's gonna be, I put it in my calculators, but 3,000 minus 40 plus 45 plus 32 plus 22. Don't forget the subtraction sign. So I'd come out to a total new weight. So this aircraft weighs more than it did originally. So the empty weight of this aircraft is now 3,059 pounds. And the total moments on this aircraft add up to be 80,424, in this case inch pounds, but we're not really worrying about the units here. Again, the biggest mistake you're going to make will be not subtracting this or adding this by accident. So just put 75,000 minus 2,000 plus 2,790, etc. All right, so at the end of the day, we go back to our formula, wham. So we have our weight, 3,059 times the arm, which is what we want, equals our moment. So we divide both sides by 359, divide both sides by 3059. Anything over itself is 1, so I'm left with the arm, and then this answer will come out to be 26.29 inches from the datum. So it moved around an inch, 1.29 inches aft of where it was originally at.